So first one, we've got a cube root of negative 64. So you need to know all your perfect cubes. If you don't, you should have a list somewhere. You can always reproduce it. You got squares, cubes. You can even go up to quartics. So all you got to do to make these lists, think about what is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. You can go through and just make the whole list. Go through as many as you need. Now for cubes, you just got to do it 3 times. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. Or you could have them memorized. Doesn't really matter. And then for your quartics, you just got to remember that you are multiplying by 1 more if you need that, which I know we do. So 1 times 1 times 1 times 1, and then 2 4 times, 3 4 times, 4 times 4 times 4 times 4, you get 256. You can write out as many of these as you want. All you need to do is make the list, and then once you've done that, you can refer to it. So we're looking for the third root of 64. That's one of the numbers I just wrote down. 1, 2, 3, 4. Since it's negative 4, which honestly, that's enough. Just looking at your options, there's only one thing that's got a negative 4 in it. Now, if you went through and checked the rest, you got a to the 6th. The long way is to write these things down. You got 6 a's. And since it's cube root, you need 3 of them. So you can make 2 sets. That's why we got an a squared. You do the same thing with the b's and the c's. Or the shorter way is just to divide. 30 divided by 3 is 10. 36 divided by 3 is 12. All that checks out. Number 2, that's a cube root of 54. 54 is not one of our cubes, but 27 is. And 54 is 27 times 2. So we can do the cube root of 27. You get a 3. The cube root of 2, we can't do that, so that just stays. There's going to be a 2 on the inside, not a 3 on the inside, so it's not these. And then looking at your variables, x to the 4th, you've got 4. That makes 1 set with 1 leftover. 1 set with 1 x leftover. They both have that. Then you look at your y's. You've got 3 sets, no leftovers. And then your z's, 1 set. So 1 z comes out. 2 z's are leftovers, z squared on the inside. And number 3, square root of 121 is 11, which they all have. X, we don't have a set of x's. We don't have a pair of x's, so x just stays inside. Y squared, that's 1 set with no leftover, so a y comes out. 11y, and then the x stays in. So now we've got a 4th, so we can look at these quartics. So we're looking for 243. 243 is not a quartic, but 243 could be divided by 81. 243 divided by 81 is 3. So we've got the 4th root of 81, which is 3. And then there's an extra 3 left over. So the 3 on the outside and the 3 on the inside. And so it's not C. It's also not A because they didn't put the little 4 in there. So you can cross out A. It's not A. So then you look at your variables. X to the 7th, that's 1 set. Oh, we can take 4 out as 1 set with 3 left over. 1 set, 3 left over, 1 set, 3 left over. They both have that. Y to the 8th. That's two sets with no leftovers. So y squared coming out, no y's left over. They both have that. And then z to the sixth. That's one set of 4 with 2 leftovers. So one set comes out, 2 leftovers. That's B. D only shows 1 leftover. So kind of the same thing for number 5. We're looking for the 4th root of 64. 64 is not on our list of quartics, but 16 is. 64 divided by 16 is 4. And the 4th root of 16 is 2. So a 2 comes out and a 4 stays in. The 4th root of 16 is 2. 2 comes out, the 4 stays in. So it's not C. It doesn't have a 4 on the inside. X to the 4th, that's one complete set with no leftovers. They all have that. Y to the 7th, that's one complete set with 3 leftover. Only one set, so it's not that, it's not that. It's got to be D. Then if you check your Z to the 6th, that's one set with 2 leftovers, one set, 2 leftovers, that works. Third root of 27, that's just 3, it's perfect. Y to the 6th, that makes 2 sets. Z to the 9th, that makes 3 sets. No leftovers, that's A. All of the equivalent forms, all you're doing is you're taking the index and you make that be the denominator. So that's 5. The 4 becomes the denominator of your exponent, so 3/4. So the 4 becomes your denominator on your exponent, so that's 2 to the 9 over 4. The 3, the index, becomes your denominator, so that's 7 to the 2 over 3. And then the 4, that becomes your denominator, so that's 3 to the 3 over 4. So these are the most confusing. These are the trickiest questions on the test. You need to know multiple steps, and you have to kind of identify along the way which one's which. So first thing, similar to what we just talked about in those last 4 examples, the denominator of the exponent would be the index. So that 3 is the third root. And inside we've got 2x because of the parentheses. They're both inside. And then the 2 just means squared. And here it's 4x to the 1/2. Only the x has the 1/2 power on it. Only the x. So it's 4, and then it's the 1/2 power of x, which means it's the square root of x. So this one is wrong because the 4 should not be inside the square root. The 1/2 power was only on the x. So this one's wrong. So we can see the cube root of 2x squared on this one and this one, plus the 4 squared of x. So far, these are both pretty similar. The difference between them is this one has parentheses, which we didn't get rid of, which matches that exactly. So that's obviously right. This one, since it does not have the parentheses, is wrong. Then, if you take that 2x squared, you square the 2, you square the x. 2 squared is 4. So you square both of them. You square the 2, you get 4. You square the x, you get x squared. Then you don't need the parentheses anymore, which is exactly like number 1 here. So 3x to the 3/4 power, that means it's the 4th root. They all have 4th root. 3x to the 3rd with the parentheses. So that one, this one's wrong because it doesn't have the parentheses. Doesn't have parentheses around the 3x to the 3rd. This one's good. And if you actually took the 3x to the 3rd and you work that out, 3 to the 3rd is 27. X to the 3rd. So that's good too. Then 2x to the 2/5. Only the x has that exponent. The 2 does not have the exponent. So the 2 remains outside. X to the 2/5 means the 5th root of x squared with a 2 outside. 2 5th root of x squared, just like that. 2 5th root of x squared, just like that. Not inside the parentheses. So it's 1 and 2 to see. So it's the cube root of 3x squared. And if you squared both of those, you would get 3 squared x squared. 3 squared is 9, x squared. So it could be a 9x squared on the inside like that. It could be a 3x in parentheses, not like number 2. Then the 5 is outside because it does not have the exponent on it. And then you do the 5th root of x to the 3rd power. 5's outside, 5th root, x cubed. 5 outside, 5th root, x cubed. 5's outside, 5th root of x cubed. The 5 is not outside, so it's not that one. So we've got 1 and 3. So these are a lot like what we were just doing, where you have to take the denominator and make it be the index. So it's the 3rd root of 27 to the negative 2nd power. Now, all that means, all that negative means, is that it's going to take whatever you get and make it be 1 over at the very end. That's all a negative exponent does. When you see a negative exponent, you should realize that that's going to be a fraction, probably like b or d. Because a negative exponent just creates a fraction, 1 over whatever you got. So the cube root of 27 is 3, so that's the same thing as 3 to the negative 2. 3 squared is 9, so that's 9 to the negative exponent. A negative exponent, all it does is make 1 over. So it's b. Now, for the next one, number 15, it's 2 of those exact problems that you have to multiply together at the end. So it's the cube root of negative 64. Whatever you get, you're going to square that. And then you're going to do the 5th root of 32 to the 1st power. So 64, cube root. That's 4 times 4 times 4. So it's negative 4 squared. And then for 5th roots, yes, you could go through and you could write them all out. 1 to the 5th power, 2 to the 5th power. Or you could just kind of take a guess and check it. 32, if I had to guess, I'd guess 2. And then check it out. So 2 times 2, 5 times. 2 times 2 times 2 times 2 times 2. That is 32. The 5th root of 32 is 2. So negative 4 squared, negative 4 times negative 4 is 16. 16 times 2 is 32. So 125 to the 2/3, that means cube root of 125. and then square it. Cube root of 125 is 5. Square that, you get 25. Pretty similar question, except this time we got a negative. So the cube root of negative 125 will be negative 5 this time. And then square it. And we have 9 to the 1/2. That means square root of 9, which is just 3. And then negative 5 squared, that's 5, negative 5 times negative 5. 25 times 3 is 75. So number 18 is pretty similar to what we did a couple of questions ago. The 3 means cube root. And then to the negative 4th power. So cube root of 27 is 3. The negative exponent just means 1 over, so that's 1 over 3 to the 4th. And 3 to the 4th is 81. So B. Number 19, same concept. Square root of 16, the negative 3rd power. And then 81 to the 1/4 means the 4th root of 81. So square root of 16 is 4. The 4th root of 81, we just did that a second ago. 3 to the 4th is 81, so that's just 3. Now, the negative exponent makes that be 1 over 4 to the 3rd. And then 4 to the 3rd, 4 times 4 times 4 is 64. We have 1 over 64 times 3. You could think of that as 3 over 1, so you get 3 over 64. So 16 to the negative 3/4, that means 4th root. 16 to the negative 3. 4th root of 16, that's 2. 2 times 2 times 2 times 2. So the negative exponent means 1 over, and then 2 to the 3rd is 8, so 1 over 8. That means cube root, negative 27, squared. This means 5th root, 32, squared. So you get a cube root of 27, negative 27, so you get negative 3. Then you do the 5th root of 32, it's 2. Negative 3 times negative 3 is 9, and then 2 times 2 is 4. 9 times 4, 36. So, for these, you got to use the exponent rules, which means power to a power. Right here, we've got an exponent outside parentheses, which means we distribute that power. And you multiply. You multiply them. So 2/5 times negative 10. 2/5 times negative 10, that'll be negative 20 over 5. And then negative 1/5 times negative 10. 1 times 10 is 10 over 5. Negative 20 over 5 is negative 4. 10 over 5 is 2. And we know that negative exponents, you're just supposed to move them down, make it be 1 over. You can say y squared over 1 if you want. So you can see what goes on top is the y squared, and then the x to the 4th on the bottom. So same steps for this one. You can distribute your exponent. -3 times -6. That's 18 over 2. And then 4 times -6. That's -24 over 3. 18 over 2 is 9. -24 over 3 is -8. So that negative exponent means it should be 1 over. So that's x to the 9th, and then 1 over y to the 8th. So we have an x to the 9th on top and a y to the 8th on bottom. Let's see. So it's the same steps. You got to distribute that exponent. So it has to go to the 27, it has to go to the x, and it has to go to the y. Now, since the exponent that we're distributing is 1 over 3, we have 27 to the 1 over 3. We have x to the 3rd to the 1 over 3, which makes it be 3 over 3. You multiply the top numbers together and any denominators, the bottom numbers together. Same idea with the y's. You get -9 times 1 over 3. Multiply the top numbers together, the numerators. So 27 to the 1/3 means cube root of 27, which is 3. X to the 3 over 3 is just x. And then y to the -9 over 3 would be y to the -3, which would be 1 over y to the 3rd. We have a 3x on top. We have a y to the 3rd on bottom in the denominator. C. So same thing with this. Distribute that exponent to every piece. So 25 to the 3 over 2. X to the -6 to the 3 over 2. So you multiply your numerators. 6 times 3 is 18. And then y to the 4th to the 3 over 2. Multiply your numerators. That's 12 over 2. So 25 to the 3 over 2. That means square root of 25. And then to the 3rd power. So that's 5 to the 3rd power, which is 125. -18 divided by 2, that's -9. The -9 turns into 1 over x to the 9th. And then 12 divided by 2 is 6, so you get y to the 6th. So you have 125 and y to the 6th over x to the 9th. Distribute your exponents again. So you multiply the 4 times 9. 4 times 9 is 36 over 3. And then y to the -1 times 9 is -9 over 3. 36 divided by 3 is 12, so that's x to the 12th. Y, -9 divided by 3 is -3. Since that's a negative exponent, you make it be 1 over. We have x to the 12th times 1 over y to the 3rd. So x to the 12th is on top, y to the 3rd is on bottom. C. Distribute your exponent to every piece. Again, 1/3 power of 343 means the cube root of 343. X to the 6 times 1 over 3 become 6 times 1 is 6 over 3. Then the negative 9 times 1 over 3. So the cube root of 343 is 7. 7 times 7 times 7. And then 6 divided by 3 is 2, so that's x squared. 9 divided by 3 is 3, so that's y to the negative third. That negative exponent just means it needs to move down. So we have a 7x squared and then a y to the third on the bottom. So when you're solving an equation that's got square roots, you have to isolate the square root, get it alone by itself, and then square both sides. When you square both sides, you have to remember that you have to FOIL out if it's x minus 2 or something like that. You have to FOIL it out. So I always write it twice and then multiply it out. So the squared cancels the square root, so we got 3x plus 12 by itself. And then you got to multiply this out. So x times x is x squared. X times negative 2. Negative 2 times x. Negative 2 times negative 2. Then you've got x squareds, you've got x's, you got to get everything together on one side. So we're going to subtract our 3x over. And then we got to combine all of our x's. So a negative 2x, a negative 2x, and a negative 3x makes negative 7x. You're also going to move the negative 12. Move the 12, subtract 12. 4 minus 12 is negative 8. So we've got everything on one side. Once everything's on one side, you can solve by factoring. So the two numbers that multiply to be negative 8, add to be negative 7. Negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. Then you have to solve these. So you get x minus 8 equals 0 and x plus 1 equals 0. X equals 8. X equals negative 1. Now, what you need to be careful about is it's asking for the extraneous root, which means which one of these do you get as an answer that does not work when you plug it back in. So we just got our answers. Now let's look at what works when we plug it back in. So plug in the 8. 3 times 8 is 24 plus 12. So that's the square root of 36, which would just be 6. Plug in the 8. 8 minus 2 is 6. So that one works. But it's asking for the extraneous root, which means the one that doesn't work. So it's probably the negative 1. So when you plug in the negative 1, that's negative 3 plus 12, that's 9. Square root of 9 is 3. But when you plug in the negative 1 on the right side, you get negative 3. So yes, that is the extraneous root. Negative 1 is the extraneous root. It's a tricky question because it's asking you to solve it and then say which one doesn't work. So here's another one of the same thing. Square, isolate it, square both sides. So when you square both sides, the square root cancels. X minus 1 squared, you got to FOIL that out just like the last time. X minus 1 times x minus 1. FOIL out. X times x. X times negative 1. Negative 1 times x. Negative 1 times negative 1. Positive 1. Get everything together. Move your x over. Move your 5 over. Negative x, negative x, negative x makes negative 3x. And then 1 minus 5 is negative 4. Once everything's on one side, you can factor it. Once everything's on one side, you can factor it. Multiply to be negative 4. Add to be negative 3. So that's negative 4 plus 1. So x minus 4 equals 0. X plus 1 equals 0. X equals 4. X equals negative 1. Again, it asks for which one's the extraneous, which means which one doesn't work when you plug it back in. So plug in the 4, you get square root of 9. And plug in the 4 on the right, you get 4 minus 1 is 3. Square root of 9 is 3, that one's right. Plug in the negative 1. You get square root of 4. Negative 1, you get negative 2. That's the extraneous root. D. So when you're solving, and it's got the 1/3 exponent. 1/3 exponent just means cube root. So since that's just a cube root, you get rid of a root by raising it to the power. Since that's a cube root, we're going to cube both sides. So the cube cancels the cube root. So you have x squared plus 28x, and then negative 3 to the third. So negative 3 times negative 3 times negative 3 is negative 27. So just like the last problems, you have to solve this by getting everything on one side. So we're going to add that 27 over. So that's plus 27 equals 0. We need to come up with two numbers that multiply to be positive 27 and add to be positive 28. So when you solve that, you set each factor to 0. You get x equals negative 27 and x equals negative 1. And you got to check to see which ones are, if any of them are extraneous. So plug in the negative 27. Plug in the negative 27. We get negative 27 squared is a very, very large number. So we could also kind of think through this a little bit, maybe save a little bit of work, because 27 squared is going to be a very large number. So our only possibilities are 3 and 4. So it could be maybe 3 only. It could be or 4 only. Or it's both of them. So we know it's not option C. So when you plug in negative 1, plug in negative 1. Negative 1 squared would be 1, plus 28 times negative 1. And that's all inside the cube root. So we have negative 27 inside the square root, which is negative 3. So that one works. And then when you plug in the negative 27, I would use a calculator for this one. 27 squared is 729. And then 28 times negative 27. So 729 minus 756 is negative 27. Inside the cube root, that one worked out. It's both of them. So, same type of question. We know this 1/3 means cube root. So that means we're going to do cubed on both sides to cancel that out. So you get x squared plus 6x equals negative 2 to the third is negative 8. Move the 8 over. You get a positive 8. Now we got to factor that. Multiply to be 8, add to be 6. That's 4 times 2. So you get x equals negative 4, x equals negative 2. Plug them back in just to make sure. Plug in the negative 4, you get 16. 6 times 4 is 24. That's negative 8. And the cube root of negative 8 is negative 2. That's true. You do the same thing with the negative 2. You plug that in, you get negative or positive 4. And then 6 times negative 2 is negative 12. That's also negative 8. And we know negative 8 to the 1/3 is negative 2. So they're both true. Negative 4, negative 2. That's 1 and 3.